Chapter 2.3, the product and quotient rules and higher order derivatives. Day 5. Today we're going to look at higher order derivatives. And a higher order derivative, for lack of a better term, is just the next derivative beyond the derivative. So if we have a function, f of x, and we take the derivative of it, we call it f prime of x. Well, if we take the derivative of the derivative, that's a higher order. It goes f double prime, or f, the second derivative of x. All right? And we've kind of talked about this with the position function. You take the derivative of the position function, you get the velocity function. And if you take the derivative of the velocity function, you get the acceleration function. So acceleration is the second derivative of position. All right? And it's as simple as it sounds. To find the second derivative, you first take the first derivative. So the derivative of 6x cubed plus 5x squared minus 9 is 18x squared plus 10x. And the 9's a constant, so it's 0. And then you take the derivative of that, you get 36x plus 10. So the second derivative of 6x cubed plus 5x squared minus 9 is 36x plus 10. Okay, give the second derivative. Now for this problem, it's easier to simplify it. We could use quotient rule on this, but that'll get quite long and messy, and then you're going to have to take the derivative of that. For this, let's treat this as a 2-on-1. All right, feel it as two separate problems. So we can write this as x squared over x to the 1/2 plus 1 over x to the 1/2. And then to simplify it, when you're dividing exponents with the same base, you can subtract the power. So this is x to the 3/2 plus x to the negative 1/2. And so then our g prime will be 3/2 x to the 1/2 minus 1/2 x to the negative 3/2. And then our second derivative, or g prime prime, not proper vocab there, double second derivative, will be 3/4 x to the negative 1/2 plus 3/4 x to the negative 5/2. So to find the second derivative, you must first find the first derivative and go from there. Okay? A particle moves with the given position function. Find the average rate of change on 2,4. So first, our average rate of change is the change in position, p of 4 minus p of 2, over the change in time, 4 minus 2. P of 4, we got 16 minus 9 is 7. Now let's just plug this into our calculator here. 4 cubed minus 27, that's going to get pretty big. Let's show you how to use a table on your calculator if you have not done so yet. All right, so our function, we'll enter that into y1. Let's go x squared minus 9 times x cubed minus 27. Okay, we want p of 4 and p of 2. Okay, p of 4 is 259. Minus p of 2 is 95 all over 2. Right, when we simplify that, 295, oops, sorry, 259 minus 95 divided by 2. The average rate of change is 82. All right? And to find the instantaneous velocity, well, that's just the derivative of position. So take our position function, take the derivative of that. We could FOIL that out, or we could use the product rule. In this case, I'm going to use the product rule. It'll be first derivative of the second, which would be 3t squared, plus second, and notice how I'm keeping these grouped, times derivative of the first, 2t. All right, so there's our instantaneous velocity. We could find the velocity at any time. Find the instantaneous acceleration at t equals 3. Well, for acceleration, that's the second derivative. So we'll take our first derivative and take the derivative of that. So let's go back to here. Take our first derivative. Copy that down. Paste that up there. We'll take the derivative of that. All right. Now for this, it would be probably a good idea to clean this one up. This one seems to be a little messy. We used the product rule here and the product rule there. So let's just distribute p prime of t, or velocity, equals 3t squared times t squared is 3t to the fourth minus 27t squared. Distribute there. 2t to the fourth minus 54t. Now we can clean this up a bit. 5t to the fourth minus 27t squared minus 54t. And we'll do our second derivative, which is our acceleration. And that'll give us 20t cubed minus 54t minus 54. And the question says acceleration at time t equals 3. We'll plug in 3 for t. So we'll go 3 in for t. I'm going to change it to x on the calculator. We got 20t cubed minus 54t minus 54. The instantaneous acceleration is 324. Find the second derivative of this function. Again, this is a 3-on-1. To do a 3-on-1, it's best to split and simplify. So that would become x plus 2 minus x to the negative 1. As we do our derivative there, we got 1 plus x to the negative 2. And then we'll take the derivative of that, and we got negative 2x to the negative 3, which you can leave like that, or some people insist to simplify to negative 2 over x cubed. Find the second derivative of this function. Well, yesterday we talked about the derivative of secant. The derivative of secant is secant x tangent x. And then we use the product rule. We will go first times the derivative of the second. Derivative of tangent is secant squared of x plus second derivative of the first. And the derivative of secant is secant x tangent x. All right, we can clean this up a little bit, or we can leave it as is. I'm going to clean it up by factoring. Each of them has a secant in it. So we got secant times secant squared of x plus tangent squared of x. All right, here we're given the second derivative and we want to find the third. That's what the 3 hashes mean and the 2 hashes. Well, let's rewrite our second derivative. So we don't have the fraction. And then we'll take the derivative of that. The third derivative is 2x to the negative 2. Or if you insist, 2 over x squared. And finally, if we have the fourth derivative, once you get to a certain point, you just stop making little hash marks because it gets to be messy and hard to read. So if we have the fourth derivative and we want to find the sixth derivative, it's quite simple. We must go through the fifth derivative. Right? So first we find the fifth derivative, and that would be 2. And then our sixth derivative, well, the derivative of a constant, is 0. So our sixth derivative is 0. Right? So in review, a higher order derivative means a derivative beyond 2, or beyond the first derivative. To find the second derivative, you first find the first derivative. To find the third derivative, you first find the first and second.